At this stage, we should have persistence up and running. Our next step will be to implement business logic for our microservice, and we'll put it into a beacons controller component. Since it's a simple data microservice, the controller will implement a few basic CRUD operations. Plus, we'll put there a calculate position business method that will triangulate position of person or device based on the beacon UDIs detected around it. Additionally, this component will implement a few basic interfaces from Pip.Services toolkit that will allow to manage the component lifecycle. To test the component, we'll put an automated test class. Create logic folder under service project. In this folder, put beacons controller class. This class will implement iBeacons controller interface that we defined previously, and iConfigurable and iReferenceable interfaces from Pip.Services toolkit. I would suggest to comment iCommandable interface and property and method related to it. We'll come back to that interface later on the next step. The controller component must have a default constructor without parameters. Then, to implement iConfigurable interface, we'll put configure method that receives config parameters. If we need to pass configuration to this component, this is the place where you can receive them. The next interface is iReferenceable. It is used to pass external dependencies to this component. Instead of using dependency injection that was so popular in other languages, Pip.Services toolkit implements a Locator pattern. The benefit of this pattern that it can be implemented in any language even if it doesn't support reflection. This interface requires setReferences method that receives iReferences parameter. Essentially, it's just a map where we pass external dependencies to the components. The dependencies can be retrieved by key that could be any type of object. But in Pip.Services toolkit, most often we're using descriptor as the key. Descriptor is the object that can be matched by 5 different fields. The first field called logical group, and in our case it's the name of the microservice or name of a library. The second field is logical type. You can think of an interface. The third one will be physical type or implementation type. In descriptor it's called kind. So in our case, if we need to retrieve a specific dependency with a specific implementation, like let's say memory persistence or MongoDB persistence, this is where we can specify it. The fourth parameter will be unique component name, and the fifth one is the component version. Descriptors can be matched with key defined in the references and retrieve like one or several parameters that matching our descriptor. If we put null or star, it means that this value can be matched to any value in the key. So this configuration means that we are retrieving persistent components that belong to beacons microservice version 1.0, and it can be any type or any name. Then we'll use getOneRequired method. We'll retrieve exactly one reference. Usually if we have several persistent components, we'll get the first one, and it will be required, which means that if nothing is found in the dependencies, this method will throw an exception. Also, you can use getOneOptional, and this method will return null if there is nothing in the references. So the retrieved reference to persistence class will be used in the implementation of the business methods. Most of the method will just delegate execution to the persistence. As you see, when we call getPersistence, getBeacons method will be passing it to getPageByFilter in the persistence component. GetBeaconById will be delegated, getBeaconByUDI. Then create, update, and delete operations also will be delegated. Just in create and update operations will be setting default values. The most interesting part of the beacon's controller interface is calculate position method. In this method, we receive site ID and array of beacon UDIs that detected a route person or device. If UDI's parameter is empty, then we return null without even calculating the value. The next step is to retrieve beacons by site ID and UDIs. We'll be calling persistence getPage by filter. Since we're calling it only the first time, we'll receive the first page. But the page usually contains up to 100 objects, so it will be more than enough to get beacons around us, since we're not expecting more than a few of those. After that, we are going to iterate through beacons, and if their center point is defined, then we will get coordinates and sum them up. At the end, we are going to create a result object, and we will calculate the coordinates of the result point as weighted average of latitude that we calculated iterating through the beacons, and we return it as the result value. So it's not the most precise method, but for short distances it should give us pretty accurate values. After we created a beacon's controller component, let's go into service test project and create logic folder. Put in the logic folder beacon's controller test class. This test will be very similar to the test that we implemented for our persistence. We will define two beacon test objects, and in the setup method in the constructor we are going to create a few components. First, we'll create persistence and configure it with empty configuration parameters. Then we'll create controller component. After that, we need to link controller and persistent components with each other. To do that, we'll need to create a references object, and we'll put two references there, to persistence component and controller component. As the key, we'll be using descriptor. The group in the descriptor will be beacons, that's the name of our microservice. Then we'll have logical type, persistence or controller. In the case of persistence, we'll specify that we'll be using memory persistence. Since all persistence behave identically and we tested it using reusable test suite, we can use memory persistence just to make things faster and easier for us. The fourth parameter will be name, and in our case we'll just skip that parameter, and the last one is the version. Since this is the first version of our microservice, we'll just put the version 1.0. Then we will pass these references to setReferences method in the controller, where it will retrieve dependency to the persistence component. After that, we can open persistence. In our dispose method will be closing persistence, and our CRUD operations will be similar to the class that we defined for the persistence. We'll create the first object and test the object that was created, that it should be matching. Then we'll create the second beacon objects, get all beacons with empty filter, and we should receive exactly two beacons that we just created. We will get the first beacon, change human readable label and update it, check that the label was successfully updated. Then we'll retrieve beacon by UDI, check that we get the right beacon. Then we'll delete beacon by ID and try to retrieve it. Since the beacon was physically deleted, we should receive null. We're not going to test different filters because that functionality already was tested at the persistence layer, and there is no need to repeat it here. The next test method will test calculate position business method that we added into the controller. It starts the same way. We'll create two beacons, then we'll call calculate position method and we'll pass UDI of the first beacon. Let's see the coordinates that we defined in the test object. the coordinate of the first beacon that has UDI 0001 is 00. Coordinates of the second beacon is 22. So when we call calculate position for the object around the first beacon, then we should receive coordinates that exactly the same as coordinates of the beacon itself, so it will be 00. In the second case, when our device can detect both beacons, the position would be exactly in the middle between those beacons. So since the first beacon has coordinate 00 and the second 22, the position in the middle will be 11. As you see, this test is almost identical to the persistence test, and in the reality, when we implement them, we'll just cut and paste code from the persistence and make necessary additions to it. Now let's rebuild our project and run our tests. Now we can see that all tests executed successfully. It means that our controller working correctly. Good work! Now we have persistence and business logic working. Our next step will be to put HTTP interface to our microservice so it can be called by external consumers.